Hi, I'm Sachin Prabhu, a software developer with IBM, and I have the pleasure of doing the last presentation for the day. I promise I'll be quick. I do have a pre-recorded demo. I'll be narrating as we go. So before we start, the title, "Opening Windows to the Ceph World," it's inspired by the Samba tagline, which is "Opening Windows to the Wider World." Since we are, in this case, we are talking about Ceph SMB here, opening windows to the Ceph world. Before I start, the team. So I'm part of the CephSMB team within IBM. Many of the team members are from Red Hat, who moved over to IBM after the acquisition. Uh, we do have a we do have a GitHub account. This is called Samba and Kubernetes. This was created when we were creating a Samba operator for Kubernetes. This talk is not about Kubernetes, but a lot of components created at that time are used within CephSMB. So let me just quickly go through the projects. You have the Samba containers. These are containers which run SMBD and other allied services required to export the file system. Samba CC is a wrapper which is used to stop the SMBD service. It reads a JSON file and it creates the Samba configuration required and then starts the SMBD server. Samba build is a project where we do nightly builds of upstream Samba, which we use for our testing. And finally, we have Samba integration testing, where it's a test runner which runs a set of tests against a set of tests for Samba against a clustered file system. So we started off exporting a GlusterFS file system. And now we do GlusterFS, we do CephFS, we also do a few other file systems. So we are at Ceph Day. We all know what Ceph is. We will be focusing more on CephFS, which is the clustered file system built on Ceph. SMB, it's the Network File System Protocol, which is natively used by Microsoft, and also by Mac OS X. Linux clients are also available. And the latest SMB version is SMB v3.11. We will be talking about Samba a lot in this presentation. This is the open source SMB file server. The URL for the project is given there. Before we start with the CephSMB talk, yes, we were always able to export CephFS using over SMB, but this was a very manual process. The documentation required to export this was scattered, and some of the components were no longer maintained. I'm talking about the VFS module required for Samba to export CephFS over SMB, or for Samba to export CephFS over SMB. We have replaced this with a newer module called VFS Ceph New, which takes advantage of the low-level drivers available with libCephFS. So the CephSMB module, manager module, we've added a new manager module called SMB, which allows us to easily create SMB clusters and the required shares to export the CephFS volumes. We create the spec files and we then pass it on to the orchestrator, which is pass it on to the orchestrator, which creates the containers required to export this CephFS volume. So orchestration, it reads the SMB service spec, it spins up the containers. These containers are split into two. The first one is the init containers. These containers essentially make sure that everything is in order, the resources are available, and then creates the configuration required to start Samba, to start the other services required to export the file system. So the other sidecar containers created are SMBD, which is the file server. You have CTDB, which is required for clustering. You have WinBind, which does the SID to UID mapping. And then we use Prometheus for the metrics. Another component I haven't listed here is the proxy component, which I will talk about later. So CephSMB, it's available on Tentacle. It supports both user-based access control as well as it supports Active Directory integration. Clustering support is available. Uh, and we can also pass in custom Samba share options, but this is discouraged and is only recommended for use by developers who want to test new Samba configurations in that particular cluster. And the docs for the CephSMB or the SMB manager module is available on the website. So there are two ways to create the SMB service. One is the imperative method, where we actually run the CephSMB command on the command line. So we use these commands to create clusters, and then for the cluster, we can then create shares. So a cluster is simply a logical grouping of shares. We can similarly also delete resources from the command line itself. The other option is using the declarative method, where we provide the resource definition, in either a YAML file or a JSON file, and we simply use CephSMB apply to create the resources. Now, resources can be the cluster, shares on the cluster. If we are using Active Directory, we would also need to provide another resource called the join auth, which requires the Active Directory credentials to join the Active Directory server. And then users and groups. If we do not want to connect to an Active Directory, we can provide the users required in a separate resource. So I have a demo. Tony? Oh, sorry. You could stop that as well, that's fine. Okay, yeah. So this is a demo. This is a pre-recorded demo, which is the same demo which a colleague of mine, John Mulligan, had demonstrated at CephLCon last December. So we start off by enabling the SMB manager module. And we initially create a file system, a CephFS volume called CephFS. And in this case, we are creating a subvolume group called demos. Now, within this subvolume group, we are creating 4 separate subvolumes. And each subvolume will be used to host a share within that particular cluster. So we'll be creating 2 clusters, one with user authentication, the other with Active Directory authentication. So here the subvolume is created within the subvolume group demos. And we also set the mode to read, write, execute for everyone. This is done for easy permission handling when we create the share. So here we are labeling the hosts in this Ceph cluster. So we set the first machine in the cluster to the label first, and then we set the second, third, and fourth machines to label CS2. Now these will be used to create the clusters. So the first cluster, we just use user authentication, and we use the imperative method here to create the cluster. So we see that we don't have any clusters created. So we create a cluster with the CephSMB cluster create command. We name it starter. We use user authentication, and we provide, in this case, we provide the user details on the command line itself. We're creating 2 users here, test and test2. And we set placement to the to the host marked starter, or marked first, sorry. So this is this cluster is running on a single node. So there is no clustering enabled for it. So it returns success, and it provides the part of the definition for the SMB service. And then within that starter cluster, we create a share called share1, where we pass the CephFS volume and the subvolume set to demo/uv1. So that's the first of the 4 volumes we created. Here we are exporting the root of that particular subvolume. Here we create a second share, and we export the second volume. The difference here is we use the share name, so which is slightly different to the share ID. So we use the CephSMB show command to actually to see the services created. We can also use the show command to see a particular type of resource. In this case, we are just seeing the shares created on the start cluster. We can also print it out in YAML format. So we use the ceph arch ls command to see if the service has been started. So the cluster has been started. This is the SMB cluster with user authentication. Here we use the SMB client command. This is part of the Samba packages itself, the Samba client packages. We use the SMB command to connect to the share. And we connect as the first user, which is user test. We then upload a file to this particular share. Now we log in as the second user to the same share. Here we use the second user to log into the second share, and notice here we use the share name which was passed. So now we create the second cluster. The second cluster now connects to the Active Directory server. Here we use the declarative method to create the share, the SMB cluster, the SMB cluster. So the difference is here we use public addresses, which this is a clustered service because there are multiple nodes involved. So we start so this SMB service, the SMB management module detects this. It starts CTDB and it uses these floating IP addresses. These are the public IP addresses which you use to connect to that particular service. So in this case, we will enable clustering. And of course, we also provide the auth info required to connect to the Active Directory server. So in this case, it's run on 3 nodes with label CS2. So the cluster is created. We run the ceph arch command to see if the service is up. That's sme.ccad, ccad. Same, we export it as YAML file, the same file. The second cluster isn't up yet, but the next command, we will confirm that it's up. It takes a while. It's up now, and it's running on 3 different nodes. So we now move to a Windows client machine, which is connected, which is part of the Active Directory network. So we use one of the public IP addresses, which was passed within the Samba spec. Since it's part of the Active Directory, we do not need to log in again. We are already provided with the list of shares. And we can, to test whether it's working, whether we can create files on it, we just create a test file on it. Now, to show that we can host multiple clusters, here we just connect to the first cluster again. This one requires user authentication. So we should see a pop-up asking for the username password. There. And we should see the file which we had uploaded to test it. So this is to demonstrate that we can run multiple clusters on the same, SMB clusters on the same Ceph cluster. They could use different types of authentications. They could be connected to different AD servers. So that's an example. Just quickly going through how these services are started. So we use we create SystemD services, and we can see the status for this is the first cluster, which just contains the init cluster, which is started, and the SMBD services. So we can look at the logs for the init service. So these containers are, in this case, are started by Podman. So this is one of these services which was run. So this is config watch, which checks to make sure that the configuration hasn't changed. If it changes, it automatically updates the SMB server. So here, this is the second cluster. This is the one running CTDB. We just looking at the other services there. We also running Winbind. Winbind, as I said, is used to convert the SIDs from the Active Directory to user IDs, which can be used by Samba. This is for logging. So we can access the log multiple ways. One of them is use the journal CTL. We just pass the systemd service name to be able to read the logs generated for that particular service. The other method is to actually, you can get the Podman container name itself and then run Podman logs. The problem with this method is if the container is restarted, you have lost the logs. So it's better to use the systemd or the journald command to read the logs. Another option for debugging is you can actually exec into these containers. Here we exec into the container running SMBD. And this also here. So in this case, we run netconflist, which gives us the SMB configuration, which is used to create that particular cluster. Here we are using the SMB client, which is part of the container itself, to quickly test that the SMB service is up and running. So the SMB spec files are created in the RADOS. In this case, it's created for SMB service. It's created in the namespace.smb in the pool.smb. So here we get the file config.smb. Config.smb is the config file which is used by Samba CC, the wrapper. Uh, Samba CC reads this config.smb and it generates the required smb.conf file and then hands it over to SMBD to stop the file server. So this is the this is the JSON file which is used by Samba CC. It's just been indented properly. And then finally, we can delete the services. We can use the CLI itself to delete the cluster. So there are two clusters, as you can see here. We can list the shares for the starter cluster. We have two shares, share 1 and share 2. And here we go about deleting the shares. And finally, we delete the starter cluster. Yeah, that's the end of the demo. So just talking about these CephFS features, this is incomplete. I've just created a list for myself. So the first one I wanted to talk was the proxy server. One of the problems we have is Samba uses a forking model whereby every new client connection coming in, it forks a new process, which then connects to libCephFS, thereby creating a new libCephFS stack. And each of these instances has their own data cache. So each of these libCephFS stack has its own data cache. And all of these unconnected caches eventually will overwhelm the system. They will end up consuming all the memory resources. So we hit a problem wherein we could handle about 100 simultaneous connections at the same time, and that was not good. So the solution we decided on was a proxy module. So a proxy service wherein the Samba servers, instead of connecting to libCephFS directly, they now connect to a proxy daemon, which then connects to the libCephFS. Thereby, we channel all these libCephFS calls through the proxy, thereby reducing the memory consumption, which is required for the data cache. Second is multi-channel support. This is already available on Samba. We've just added new documentation on how we can go about using this. The new VFS module also takes advantage of the async I/O calls provided by libCephFS. So that's giving us a slight performance boost there. Apart from that, case sensitivity. This is not a CephSMB feature. This is a CephFS feature. So when you create a new CephFS subvolume, we can provide the case sensitivity option, whereby we can disable case sensitivity. That's because the SMB protocol, which is based on the NTLM file system, it's case insensitive. So while it's case preserving, it doesn't actually look at case sensitivity. So what happens is Samba actually has to go through all the iterations to figure out if a file is available. So by disabling case sensitivity, we can improve performance a bit there. Also, snapshots are now available. So you create Ceph snapshots, and these can be accessed over Windows clients as the different versions for the file. Future plans. OK, before I get to the big one, we have IO stats, which IO stats per share. These are now exported. These will be exported through the metrics, which you can read over the dashboard. A gRPC interface has been planned. We're also planning quality of service for shares, whereby we can throttle the number of IOPS going to the share. As well as offline domain join. Offline domain join is where you do not have access to the Active Directory server, in which case you can provide it with a key tab file and join the Active Directory offline. And finally, multi-protocol support. This is at a very early stage. There are a lot of roadblocks to this, but we have started a conversation to see whether we can export an NFS and SMB. We can export the same volume or NFS and SMB at the same time, but this is right now very early. We are not sure if this will happen, how much time it would take to implement this particular feature. And finally, that's it. Sachin Prabhu. Those are my email addresses. You can contact me. Any questions? Yeah. Yes, so that's for testing. So we use SMB client with the password and clear text. One of the other things I showed you, when you do a CephSMB show in this particular video, you could see the passwords and clear text. Now that has been fixed later. We no longer show them in clear text. I think you can, by default, we no longer show them in clear text. You can possibly use another switch to enable it.